Welcome to Ask and Learn.
Let's use the ratio test to determine whether the series converges. Now we should focus on this term right here. This is our AN. AN equals, in the numerator we have the product of the first n even numbers, so 2, 4, 6, all the way up to 2n. And then here we have n factorial. So for the ratio test, we look at the limit n goes to infinity, an plus 1 over an in the absolute value. And here we can drop the absolute values because an and an plus 1 are positive. So for an plus 1, let's do this in red in the numerator. So here we have 2 times 4 times 6 all the way up to 2n. And then the last one, when we increase n by 1, that's 2n plus 2, the very last term. And then in the denominator, we see this, but now we'll have n plus 1 because of the plus 1 here. That's the numerator. Now in the denominator, an, we already know what this is. We already wrote it, the formula for an up here. So just go ahead and plug that in. Now let's go ahead and write this out over here. So here we should go ahead and rewrite this as a product of fractions. So I'll bring that n factorial into the numerator. And then also let me rewrite this n plus 1 factorial as n factorial times n plus 1. And then we still have this product of the first n evens. Now we should cancel as much as we can. We see the n factorial will cancel with this one. This is why we rewrote it. Here the 2, 4, 6 all the way up to 2n cancels in the numerator as well. And we're left over with the limit as n goes to infinity. We have 2n plus 2 over n plus 1. Oops. N plus 1, however, this limit is equal to 2, which is bigger than 1. So going on to the next page to write our summary, our conclusion. So the series from 1 to infinity, write that infinity up here on the side, 2, 4, 6, all the way up to 2n over n factorial. This diverges, again, because the limit that we got was bigger than 1. By the ratio test. And that's our final answer.